Have you ever stopped to consider just how much paper you interact with in a single day? From the moment you wake up and grab a tissue, to jotting down a quick note, paper plays a surprisingly significant role in our lives. Even in our increasingly digital world, paper is still undeniably everywhere, a constant presence in our homes, offices, and even our pockets. It's a testament to its versatility and enduring appeal. Books, packaging, even your coffee filter. That morning cup of joe wouldn't be the same without it. The average American uses a staggering amount, about 700 pounds of paper products each year. That includes everything from printing paper to toilet paper, and everything in between. That's the weight of a grizzly bear. It's a truly mind-boggling statistic when you think about it. Now imagine a world suddenly stripped of all paper, a world with no paper at all. What would that even look like? No birthday cards, no posters adorning our walls with vibrant images, no newspapers delivering the daily news, no paper towels. Simple, everyday tasks would suddenly become much more complicated. Hard to picture, right? It's difficult to fathom a world so drastically different from the one we know. Paper has profoundly shaped how we share knowledge, meticulously record history, and express ourselves through art for thousands of years. It's been an indispensable tool for communication and creativity. But how exactly do we transform a tough, sturdy tree into a delicate, versatile sheet of paper? What's the magic behind this transformation? The science behind it is truly fascinating. A blend of engineering and chemistry. It all starts in the forest, the source of our raw material, with wood primarily made of cellulose fibers, essentially the plant's structural skeleton, providing strength and rigidity. The primary goal is to isolate those cellulose fibers from the lignin and other components that make up the rest of the wood. Think of it like carefully taking apart a complex Lego castle piece by piece, with the intention of using those same pieces to build something entirely new and different. We chop, grind, cook, and press the wood, using a combination of mechanical and chemical processes, all to get those precious, separated cellulose fibers. Humans have been diligently perfecting and refining this intricate process ever since it was first invented in ancient China nearly 2,000 years ago. It's a craft with a rich and fascinating history. Today, giant, sophisticated machines and clever advancements in chemistry work in harmony to make paper faster, more efficiently, and of higher quality than ever before. Ready to take a closer look and see exactly how it's all done? Let's start our exciting adventure right where it all begins, in the heart of the forest. Our first stop is the harvesting site, where the trees are carefully selected and prepared for their journey to become paper. Let's go. The journey of paper begins now. Our journey begins in a carefully managed forest, a place where sustainability and industry meet. These aren't just any forests, they're cultivated and nurtured with a specific purpose in mind. Think of it as a farm, but instead of crops, we're growing trees. These aren't wild, untamed woodlands, they're meticulously planned and maintained, ensuring a continuous cycle of growth and harvest. It's a long-term investment, a commitment to responsible resource management. For every tree that's harvested to create the products we rely on, several more saplings are planted in its place. This ensures a steady and renewable supply of timber for generations to come. It's a cycle of renewal, a promise that we're not depleting our natural resources. This careful replanting is crucial for maintaining the health and vitality of our forests. Fast-growing softwoods like the versatile pine and the sturdy fir, and hardwoods such as the strong oak and the vibrant maple, are carefully chosen for their unique fiber qualities. Each type of wood brings something different to the table, contributing to the strength, texture, and overall quality of the final paper product. The selection process is a science in itself, ensuring the best possible raw materials. When the trees reach maturity and are ready for harvest, giant, powerful machines called feller bunchers spring into action. These impressive machines can precisely cut and neatly stack entire trees in a matter of seconds, significantly speeding up the harvesting process. Next, the limbers efficiently strip off the branches, leaving behind only the straight, clean trunks that are ideal for processing. This automated process ensures that the valuable wood fiber is free from unwanted debris. These trunks are then expertly cut into logs of various lengths, which are carefully loaded onto heavy-duty trucks or trains. These are then hauled to the paper mill, ready to begin their transformation. The transportation process is a vital link in the supply chain, connecting the forest to the factory. At the paper mill, the logs are stacked in enormous piles, creating a vast log yard. Here they patiently wait their turn for processing, a testament to the scale of the papermaking industry. Before the logs can be transformed into paper, they must undergo a crucial step: debarking. The rough outer bark simply isn't suitable for producing high-quality paper. It contains impurities and doesn't break down in the same way as the wood fiber. To remove it, the logs are tumbled inside a giant rotating drum, where they rub against each other, effectively scrubbing off the bark. In a display of resourcefulness, the removed bark isn't discarded. Instead, it's burned in a biomass boiler to generate steam and electricity which powers the mill itself. This is a smart and sustainable way to utilize every single part of the tree, minimizing waste and maximizing efficiency. Now, with the logs clean and debarked, we're finally ready for the next crucial step in the papermaking process. It's time to transform this solid wood into a wet, sloppy mush known as wood pulp. But how exactly do we achieve this transformation? Can you guess the method? Let's dive in and find out. With the logs now debarked and ready for processing, it's time to embark on the next crucial step: breaking them down into their fundamental components, cellulose fibers. These fibers are the very building blocks of paper, and extracting them efficiently is key to a successful pulping process. This transformation is achieved through a process called pulping, a fascinating blend of mechanical and chemical engineering. When it comes to pulping, there are two main methods employed in the industry, each with its own set of advantages and disadvantages. The first one is mechanical pulping, a process that relies on brute force to separate the wood fibers. And the second one is chemical pulping, which uses chemical reactions to dissolve the lignin that binds the wood fibers together. Mechanical pulping uses massive grinding stones, often water-lubricated, or rapidly rotating metal discs, equipped with sharp teeth, to essentially tear the wood apart, separating the fibers through sheer physical force. This method is known for making lots of pulp quickly and efficiently, making it a popular choice for high-volume production. However, the resulting paper is weaker due to the shorter fiber length and contains more lignin, which causes it to yellow and degrade over time. In contrast, chemical pulping begins by chopping logs into small, uniform chips, ensuring even penetration of the chemicals. These chips are then cooked in large pressure vessels called digesters, with a carefully controlled mixture of chemicals to selectively dissolve the lignin, the natural polymer that glues the wood fibers together. This process yields stronger, more durable fibers, resulting in brighter, higher quality paper that resists yellowing. As we've seen, mechanical pulping is fast and cheap, making it ideal for applications where cost is a primary concern. On the other hand, chemical pulping is slower and more expensive but makes higher quality paper that is suitable for archival documents and fine printing. In reality, many paper products use a blend of both mechanical and chemical pulps, carefully balancing the strength and cost to meet the specific requirements of the final product. Take cardboard boxes, for example. The strong chemical pulp is typically used for the outer layers, providing the necessary strength and durability to withstand handling and shipping, while the cheaper mechanical pulp is used for the wavy middle layer, providing cushioning and structural support. Next, let's dive into the most common and widely used chemical pulping method in the world, a process that has revolutionized the paper industry. It's called the Kraft process, derived from the German word for strength, a testament to the superior paper it produces. Ready for some chemistry? Because the Kraft process is all about carefully controlled chemical reactions. Here we go. The Kraft process is the most common chemical pulping method. Kraft means strength in German. Wood chips are loaded into a giant pressure cooker called a digester, mixed with a hot chemical solution called white liquor. The chemicals dissolve lignin, freeing the cellulose fibers without damaging them. After cooking, the mixture is released, and the pressure helps separate the fibers. The leftover chemical solution, now called black liquor, is burned to generate energy for the mill. The remaining chemicals are recovered and reused, making the process efficient and eco-friendly. Over 95% of chemicals are recycled in modern mills. The result: strong brown pulp. But for white paper, we need to clean and bleach it. Let's see how that's done. On to the next step. Our strong pulp is brown. Fine for boxes, but not for writing paper. First, the pulp is washed and screened to remove impurities. Then comes bleaching. Modern mills use safer methods like elemental chlorine-free, ECF, or totally chlorine-free, TCF, bleaching. ECF uses chlorine dioxide, TCF uses oxygen-based compounds like ozone and hydrogen peroxide. These methods remove the last traces of lignin, making the pulp bright white and stable. The result: a clean white pulp ready for sheet formation. Next, we'll see how this slurry becomes a sheet of paper. Ready for some machine magic? Let's go. Welcome to the heart of the mill, the paper machine, a massive football field-long marvel. The pulp slurry, mostly water, is sprayed onto a moving mesh screen. Water drains away and the cellulose fibers interlock, forming a fragile, wet sheet. The screen moves fast, aligning fibers and giving paper its grain. Some machines shake the screen to randomize fibers for strength. As water drains, the sheet becomes solid enough to hold together, but it's still soggy. The sheet is transferred to giant rollers to squeeze out more water. This is called the press section. The transformation from liquid to sheet is almost complete. Let's see how we get it dry and strong. The wet paper enters the press section. Huge rollers squeeze out water, making the sheet stronger. Absorbent felts carry away the water, making this step energy efficient. After pressing, the sheet is still about 60% water. Next, it winds through a maze of steam-heated cylinders in the dryer section. The heat evaporates the remaining water, carefully controlled to avoid warping or brittleness. Sensors monitor moisture, adjusting temperature and speed for perfect drying. By the end, the paper is about 5% water strong, stable, and ready for finishing. The science of drying locks the fibers together, giving paper its final strength. Now the paper is a giant roll, but it's not ready for your notebook yet. What's next? Let's finish the journey. The dry paper is wound into massive parent rolls, weighing tons. To smooth and finish it, the paper goes through calendaring, pressed between rollers for a glossy, uniform surface. Some paper gets a special coating for magazines or photos, making it extra smooth and bright. The paper is then cut into smaller rolls or sheets depending on its final use. For notebooks and printers, it's sliced into familiar sizes, counted into reams and packaged. Boxes of paper are shipped worldwide, ready for you to use. From tree to sheet, it's a journey of precision and scale. Next time you write, remember the science behind that page. But what about the future of paper? From tree to paper, it's a story of science, engineering, and innovation. The process is now more efficient and sustainable than ever. Recycling is key. Used paper is turned back into pulp, saving trees and energy. Every sheet you recycle helps close the loop and reduce waste. Choose recycled or sustainably sourced paper, and use only what you need. Science is part of our everyday choices. Stay curious, keep asking questions, and help shape a smarter, greener future. What everyday object should we explore next? Let us know in the comments. Like, subscribe, and share for more science adventures. See you next time.